So hello everyone. Once again, welcome back to watch another video. Which means for today we are going to focus on designing a system which is going to predict a weather. Okay, weather forecasting system. We are going to try to design using Proteus system. Okay, Proteus software basically. So for that, what kind of conditions we can place, or how we can design a flowchart again. Okay, we are going to use flowchart for this system, so we can use some formulas as well. Okay, so one by one we are going to understand that why we are going to use these formulas, or on which basis we are going to use the hardwares. Okay, so as usual, what we usually do is by default we select Arduino for our microcontroller, as a microcontroller. Okay, for the main processing part. And yes, this can be done using coding using Arduino IDE. Yes, well, okay, but what we are going to do is we are going to build a simulation based system instead of hardware. It's very difficult to do hardware in this pandemic, you know. So in this COVID situation, when we can't go out, or we are not safe enough, so for only to keep the people safe from contamination, over contamination, we can try to understand by designing one software based simulation system. So for today, we can use one display system, which is OLED display, that we can use for displaying the temperature, displaying humidity, displaying some variables for predicting the weather finally. And yes, we are going to use this humidity temperature sensor as well. So it will be by default 80 and 27, as some of you have worked with, you already know. And by default this sensor also will be carrying some value, but the maximum value for this sensor is 1100. This is basically known as pressure sensor. So anyways, let's start understanding how this is going to work. Let's try to understand the flow chart. Okay, so we have two parts of the flow chart. You can see two main files we can design easily. So how it is going to work, there is going to be one setup portion and loop portion, just like the basic given functions when you start designing a flowchart. So for setup, we are actually going to use a formula, and we are going to use since we are going to use this pressure sensor, so there is a relationship between barometric pressure and weather forecasting system basically. So how does this work? If the pressure increases, then the weather is actually clear, and if the pressure is decreasing, so we can say that it is a rainy day or rainy weather condition. So how we can be sure of it? We can just search in the internet, and you can see it depends on elevation basically. Okay, so atmospheric pressure, how it works, barometric pressure, you can search in Wikipedia, is not that much of a reliable source, but if you want to, you can search in you can just search using this term, atmospheric pressure, and it is very, I mean used. This barometric pressure is usually used using a barometer, obviously. The standard atmospheric pressure is defined by unit of Pascal. So this is the fixed formula, or you can write 101.3 kilopascal. So this value we are going to use for one formula. We are going to make a formula out of it. Okay, so what we can understand is SI unit, and this is basically dependent on elevation. Elevation means the height. Okay, altitude. altitude from sea level, from surface of ground of Earth's atmosphere. Okay, so these are the things we are going to follow. So we can do one thing, we can analyze a formula out of it. We can write predicted weather. Okay, pH, predicted weather, equals to this 101 point, this reference standard pressure, barometric pressure, into e to the power minus h. H stands for the height, the elevation, fixed elevation that you are going to use for finding this predicted weather, and then one specific height. This is one fixed formula. So if you find the predicted weather, then after that we can find one difference out of it, which is we can use one formula like this from our system. Okay, let's see the formula. Okay, so this is the predicted weather I was talking about. Current altitude, we can define a current altitude in our system, in our main flow chart, and that specific, according to that specific height, we will get one p weather, fixed p weather value. So this you can calculate in your calculator. It will be around 101 point something like 80088 or something like that. Okay, so whichever value you get, you can find a difference, which means pressure divided by 10 minus p weather. P weather is this calculated weather that you have found, and pressure divided by 10 is actually coming from, this pressure is actually coming from our pressure sensor. Okay, if you see PS1, so PS1, what does this hardware stand for? This hardware stands for digital pressure sensor, which we have used in here. So let's see the operation first, and then we can relate that how it is actually going to work. And before we go to the operation, we can go through this flowchart as well. So here we have set the altitude of 23 meter actually, so 23 meter, and you can use the display system, you can clear it. And in the previous experiments or previous you know systems that we have designed so far, we have used set cursor only in the output display message system only for once. But since we have some parameters to show into our display system, like temperature, what will be the value of temperature along with unit, pressure along with unit, okay, and then we have humidity along with unit. So these three components we are going to show, and then we have another subroutine to call, which is weather forecast. So let's go to the weather forecast. You can see we have set some formulas here, some decision making criteria. So what is our conditions? We have three conditions: either the weather will be sunny, or it will be sunny or cloudy, or it will be unknown. This usually does not show up much in the proteus. This is just for backup if the value is extreme. In extreme cases it is unknown actually. So anyways, these are the three: sunny, cloudy, or rainy. Okay, so how does these things actually work? We can see, go back to our manual again. Okay, we can understand this from one manual, lab manual. So if you instead of lab manual as well, you can find this formula. If you place the formula values, you can see that we can make one table like that. 0.25 is our, let's say, a threshold value, or limit. You can just set one limit if the value of the difference between predicted weather and pressure divided by 10 is around 0.25. Plus is greater than 0.25. On the plus side, it is a sunny day. If it is in range of greater than 0 minus 0.25 but less than 0 plus 0.25, then it is sunny or cloudy day. But it is less than minus 0.25, then it is rainy symbol, rainy day. So I think if we go to the simulation, then it will be clearer a bit. So we can set the cursor again. So let's see what are the values of our cursor. Let's say here we have 5, which means the first line will be used for showing when the simulation will be running the simulation. You can see the first line will be used for showing the temperature, the second line for pressure, the third line for humidity. Okay, how the third line is for humidity, you can see it is the cursor. Okay, understanding the cursor. And the text size, we have used very small size 1. Okay, if we use a bigger value, then all the outputs, all the variables won't be able to show as well. So here the last line will be used for determining the weather. So anyways, more or less you have understood the basic of our system. So let's go to the schematic capture and give a play option, and let's see what happens. So as you can see from our flowchart, we were supposed to show 4 different variables in the output section, which is temperature, pressure, humidity, and weather. Okay, so as you can see, the pressure is the highest one. If we try to increase the value of our pressure sensor, it does not increase as much. It is around 1100. So let's try lowering the value of our pressure. Since we can also control the temperature, we can control the humidity from this pressure sensor. From pressure sensor, obviously temperature can be controlled. Just you can reduce or increase the value of this temperature. So you can see I have taken, let's say, 27 degrees. So you can see the temperature is no longer 25 degrees. So since we are going to measure the vary the weather, actually 3 different weather conditions we have. So it is dependent, according to our flowchart, it is dependent on pressure only. So we don't need to vary the temperature or vary the humidity if you want to vary the humidity of your system. Okay, so what you can do, you can use this humidity sensor, and already humidity is selected, so you can increase or decrease it, around 90. You can see the humidity is 90%. So that is totally manual if you want to, but our system is dependent on this pressure value. So as the pressure is going to decrease, you can see the weather will turn from sunny to sunny or cloudy, and then after that it will be at further decreased pressure, it will be around rainy day will be shown. So for which value your weather will change, that you need to note down for now. Okay, so you can also make a data table if you want to. So I'm just decreasing the value of the pressure, so it is 109391. Okay, still now you can see it is sunny. So let's reduce the pressure a little bit more, let's say 1030. Okay, so it's 1030, the pressure is 1030, yet still you can see the weather is sunny, so it is a high pressure situation going on. So let's reduce the pressure a little bit more. See, it is sunny cloudy. So now we are going to check at which pressure value. Okay, so here you can see the unit is fixed, hectopascal. So at which value, so let's see 1014. Okay, so it is still sunny. So when it is 1013, it is sunny as well. Okay, it is sunny as well, sunny weather. So when it is 1012, it is becoming sunny or cloudy. So you can write that above 1013 pressure, or 1013, when it is equal to 1013, then your weather is sunny. But when it is becoming 1012, okay, 1012, then only you are getting, then and also up to which pressure, 1009. Okay, 1008, let's see what happens, sunny and cloudy as well. 1007, okay, in this sector 1007, you are getting rainy. Okay, so from 1008 to 1012, you can say this small amount of range of pressure values is responsible for showing sunny and cloudy weather according to the formula we have given. Similarly for rainy, you can see 1007. Let's decrease the value up to 500 or something like that. Okay, 900. Let's see what happens. 978. It is rainy as well. So try for some lower value. Still rainy. Okay. For 500. $700, still rainy. Okay, so we are just decreasing the value of our pressure. Okay, barometric pressure, still rainy. Okay, but it cannot be manually written as 0 or 500. If you double click it as well, it won't be possible. So that's the reason why we are just varying using this plus and minus controlling factors here. So let's try for 500 something, still rainy. Okay, so let's try for 0 or 10, very lower value, and maybe we can see unknown at some point of time or not. So how is this full operation actually working? So that is the main criteria to know for now. So many of you may have this confusion. So it does not go below 300. Okay, the pressure, the value for pressure does not go below 300 hectopascal. So anyways, let's stop this simulation. So how is this actually working? Why it is showing the rainy or sunny weather or sunny or cloudy? Because when you're going to make this pressure is basically the value for from that the value of pressure you are calculating from your barometric pressure sensor. Okay, digital pressure sensor. So let's see which value we were thinking. Let's place 1007 here. Okay, in this pressure variable, in this formula right here. Okay, 1007 divided by 10 minus this value. So you can calculate it using the calculator, and then you will find a value which is actually less than minus 0.25 basically. So if it is less than minus 0.25, then only the weather condition will be rainy condition. If you place 1013, just like we have seen before, or 1014 or 1015, or pressure values greater than 1013, then you will get values always greater than simple weather difference. Okay, you can keep this p weather constant because your altitude is not varying, altitude is same. Okay, if you vary the altitude, then your values will be different, obviously. But for 23, what we can see for our system is if the value is greater than 0.25, then we are setting up this system as sunny. If it is in between this range, okay, range means let's say 1011 or 1010. You can take any value from 1008 to 1012. Then you can find this calculation you can do in the calculator. So I guess I hope that all of you can do that. So how you're going to design this loop operation? Okay, so you might have this from the scratch. Okay, you guys can try building this system from the scratch. So we can open a new project, okay, for our system. Let's say I'm just opening another system right here. So how you can start from the scratch? So I can just delete this whole system for now. think I have deleted everything, right? No, I haven't. Okay, so I can delete it now. And weather forecast also. Just delete the whole. I have deleted everything so that I can show you from the beginning of how you can design this system. So I'm just deleting all the peripherals as well. So let's go back to the schematic capture. It is just as before, how you can start from the scratch. So I'm just going to the file and save this project. So now the file is actually containing nothing. Okay, so I can delete this remove sheet as well. Okay, so you know how to design this system. So what we can do is add some peripherals instead of in the previous systems you've seen we have started from this import project clip. From here we used to take the different components. So for today let's try a different approach. Okay, so instead of this we can actually take peripherals from our flowchart as well. So select add peripheral. Okay, so the project clips are loading basically. So from here you need one display system. So Adafruit is not from where. Okay, you can search this Adafruit as well. So if you just scroll a little bit, no, not from Adafruit, we are not going to take any components from Adafruit. We are going to take one display system from the Grove. Okay, so this is the display. We can add one component here. Okay, for the display you can see it is already here. Next we can add breakout peripherals. Okay, what sort of breakout peripherals we are going to take? We can take one pressure sensor, add it. Okay, you can see it is already added here as we have selected from here. And then we are going to take one humidity temperature sensor. So this is basically for setting up the humidity value. So we have selected 3 components. Let's see in our schematic capture, do we have the 3 components? Yes, we do have the 3 components already available here. So next what we are going to do is design the system. So how we can design the system? We are going to have 2 loops here initially. So let's rename them. We can write setup. Okay, and the other one as loop. We need another event for our display system, so we can write here display okay. So here we can take one assignment block and add some variables basically. So which variables we are going to show into our display system, and what do we need actually. So we can select these variables. You can see already these variables are by default, So what we can do is delete it for now so that I can show you from the scratch. So now it is just you don't have any assignment block. This is the initial block that you will see while opening one Proteus system. So we can assign the variables for now. So what sort of variables do you want to show? We can assign temperature because we need to display temperature obviously. So the value of temperature, let's say the data type, we can select as float. Similarly, we need another variable which is pressure. Okay, it is also float for now. We can take another variable which is humidity. So since humidity is in percentage, we can take float as well. Then another is our height. Okay, current altitude or elevation, so you can write current altitude, so you can just write it like this. Okay, so altitude value, we can take it as an integer value, or you can take it as one float as well, so it totally depends on you. So I'm taking integer for now because I'm thinking of perfect numbers. Let's say 23 is a nice number, so altitude can be integer. So next is we can have one difference. Okay, weather difference. So here also we can select float, and then we can also select another one which is predicted weather. Okay, this one is float as well. So these are the basic variables that we can select for our system. So current altitude, since it is integer value, we can place one, let's say 23 for now, for our system. So okay, so this is how we can set up the system. So now for loop, you need to initialize the LCD. So we are going to select options from here. Firstly, clearing the LCD device first. Next, we can set our cursor. Okay, so cursor, set cursor, yes, here. Okay, so here what we can do is initialize, let's say 5 and 5. We can take values of 5 and 5. You can take smaller values as well, so you can play with the values afterwards. You can just next is temperature. Okay, so read temperature. Notice one thing, we are going to select the temperature system from pressure sensor. You can also do it from temperature and humidity sensor as well. So read temperature is available in both the systems, but for now let's take it from PS1. Okay, so next we can add one. Okay, we can select temperature from here. Okay, and then we can add a message here. What sort of message you want to display? Okay, so for message display as well, you need to assign one variable. So let's assign a variable here which is message. Okay, so the message is basically string, as you know from the previous experiments. So here we can select message from here and then give a formula like temperature. Then give a space. Then we can write to string, okay, the value for unit, or you can just verify temperature, and then you could just write the unit as well, plus, and then write degree Celsius. So give a space. Okay, and then close. Okay, remember this formula for the next systems also. For showing this overall system, we can repeat. Okay, for our showing the pressure as well, so we can take one subroutine call. Okay, what we want to do is display the message. Okay, so next let's again take this LCD cursor, copy it and place it here. You just drag it here. So the next line, let's take a bigger value. If you don't take a bigger value, there will be a little bit difference, a little bit problem. So let's take a value in between 15. Okay, small value, and let's see what problem do we face. So after this cursor, we can copy this as well. or we can do one thing, instead of copying we can take the function directly from here. Okay, so we can select pressure. Okay, and then we can copy the message. So just connect it with the system. And place it here, and you can edit here. Okay, pressure, and instead of temperature, you know the unit for pressure is Pascal. So pressure is you can select from here, and Pascal is kilo. You know the unit was hectopascal from our sensor. Okay, so you can select this unit, then press OK, and after the message you need to display the system. Again, display message. So now this is a very small area. Here the unit, here we cannot initialize the humidity options. Okay, so what we can do is we cannot, since we cannot add the humidity here, so we can split this overall loop operation. So notice carefully how we can do that. Just give a right click here. Okay, and if you place a right click here, you will get delete or split. Just place your mouse in the wire and then give a right click. If you select this split, then you can see you are getting another loop here. Okay, continuation. This one means actually continuation. So here you can see it is known as interconnected. So in this portion you can actually initialize the humidity system. Okay, so what we can do is just copy and place the set cursor option as well. Okay, so set cursor is here connected, and instead of 15, let's take a bigger value of 30. Okay, so here we are going to read the humidity, so we can take the humidity from the function of humidity selection from humidity sensor, obviously. So we have selected humidity as well from here to read humidity, and then we can just copy the message. Same system, just the unit for humidity is what? Percentage, isn't it? So we are going to just edit our formula just like before. We are going to write here percentage. Okay, and in here instead of pressure we can write H. If you write H, then you will get humidity. And then here also instead of pressure you can write humidity. Okay, so this is the formula that can be displayed for humidity. And for display you need another subroutine call. Oops, not connected. Okay, let's see if this one is connected or not. Needs to get connected for sure. Okay, so this is the display message. So this is the system where you can display your full operation. You need to activate the display system. We have not activated that yet. So how we can activate that? We can use this print here. Okay, what sort of message you want to print? We can use display. So since we are going to print the message, we are going to write message here. Okay, select it and enter, and again enter. Okay, so here we are going to, we have already set the cursors for each and every variables to display, but we have not set the text color, and also we have not set the text size. So the size can remain up 1, which is fine. If we increase the size, then you can see that there will be a difference in, all the variables will not be shown. So we have 4 variables to display: temperature, pressure, humidity, and another one is weather. So we have not initiated that. Okay, what sort of weather you want to show. So for here, if you call the weather, okay, as you can see, the size area here is not enough, so we are going to split our flowchart. So what we can do is we can go to this flowchart files and select a new sheet. Okay, here we can just rename it as any name you want. So I'm going to write it as weather forecast. And since it is another file here, we need to initiate one event here. Okay, event block. So what sort of event block we can initiate? We can just zoom in a little bit for understanding it clearly. Okay, so just double click here. You can write weather. Okay, let's use caps lock just like before. Weather forecast. So you have the routine to call for now, but if you didn't use this, then you won't get to call this weather forecast. Okay, initially what we did was, since we have used this display message, then only we got this display message. So now if this was not available, weather forecast was not available, then it was not possible to show. So anyways, so in this here we can assign some formulas, right? The formulas that we were supposed to write. So let's write the formulas. These are basically, we need 2 assignments here. One is, we have already used all of these variables. These 2 variables are left: weather difference and predicted weather. So predicted weather, we can write the formula 101.3. Okay, so let's go back to the formula. Let's see what the formula was. Okay, 101.3 into kilopascal into e to the power minus h divided by 7990. Okay, so 3 into star. Okay, into e means exponential. Enter exponential to the power altitude. Okay, current altitude, divided by, we can write minus 7990, and use another bracket for this value, second bracket for this exponential, and the third bracket for the overall formula. So here we can write another assignment. We can again use another formula for this. So we can write pressure. Okay, here we have pressure divided by 10 and minus p weather. Okay, we have the predicted weather here, so enter. Okay, so this is how you can assign it. And okay, so here you have your formula, but what you can see is it is overlapping. Okay, so for some cases, yes, it might happen, it is overlapping. So what is the wiser decision? Just copy it and paste. So here you have the better block, which can be easily moved, and you can select the default one and delete it. Okay, so now you have the nice system. So next you can add some decisions. Okay, decision number 1, decision number 2, and next is decision number 3. So each and every decision will have some conditions. So let's write condition number, the outputs. Okay, what sort of thing you want to show. So here we haven't used any assignments here. So what we can do is we can add another variable. Okay, Okay, no, we don't need to add a variable actually. So what we can do is we can select message here. We are trying to display the message, so just message is fine. So we can write weather, or we can write small like this. Okay, weather, lowercase. Weather, give a space, and you can write sunny for the first case, for the first decision. And according to our system, the value was supposed to be the condition. Okay, condition for what? Weather difference, isn't it? So we can write it has to be greater than 0.25. Okay, so you can connect this. So as you can see, if it is yes, then it is supposed to show the sunny weather. So we can just give a right click and swap yes or no. And then if the weather difference is not greater than 0.25, then we can use the second decision box. So here we can write is in a range. Okay, so it is less than 0.25 and so we can drag it. It is greater than how much? Minus 0.25. Okay, so this is one condition that we can write. So again, as you can see, overlapping. Okay, so what we can do is delete this decision box. Again, overlapping. So what we can do is copy here and paste it somewhere, the next line, and delete this box. So decision number 1, decision number 2. If it is yes, we can swap it. Okay, again we can swap yes or no. If it is yes, then we can place one message. So we can just copy, place it here. Another message is the second message. So the second message was supposed to be sunny or cloudy. So we can just connect it and edit. Okay, so here what is the editing? Sunny or cloudy. So we can write okay, so cloudy like this. And then the next decision, so again another decision box we can select here. So here if the condition is yes, then we can swap it. Okay, we can just write weather difference is less than minus 0.25. Okay, so here you have this one, and then copy, paste. So just connect it, double click. So here instead of sunny cloudy, you can write another condition that was remaining, which is rainy. So here we have the system. So now let's connect it, connect all the systems that we have. So if the the difference, weather difference is not in between any range, no. Okay, so this, for this condition, what we can do is have another assignment block, and we can write here weather difference, no, message. Okay, unknown. But this does not activate, as you have seen from the simulation. So we need to call the system, isn't it? So let's call the system. Where is it going to be? Weather forecast, or is it going to be the display? What do you think? Obviously it is going to be the display, because if you don't connect this overall flowchart with the display system, then it is not supposed to work, isn't it? So let's join all the connections. Just join the connections, okay? So now let's give a save and use this debug is already activated and build our project. So it will take a little bit of time for building the project, and after the project is being built, when once you have the compiled successfully output, okay, if it is, I mean the command is compiled successfully, all the flowchart functions are correct, then it is going to be supposed to be compiled successfully. And after this one is done, we can use the simulation button. So let's wait for a bit and see what the, yes, you can see the compilation is successful. So let's give one simulation and go to the schematic capture. As you can see, the so it is a drastic change, so we need to use one delay function here, okay? So as you can see, drastic change and humidity, the lines are not, I mean, nice enough in the display, right? Weather line is also not nice because in the weather function we did not use any cursor, set cursor. So we are going to use that now. So let's set a cursor here. Set cursor option we need to select from here. Where is the set cursor? Yeah, here, this one. Okay, so we can just connect it, and here we can take 5 and let's say 40, okay, and in between humidity and pressure. So as you can see, this is 30. We can just take a value of around 20, I think, so this would be fine. And we are supposed to use a delay function. So here 100 millisecond is very less of a value. Let's take 2 seconds, okay? So we can take 1 second is also nice for drastic changes, but let's take 2 seconds and then give a save and just simulate. So it is going to build again because we have made some upgrades. Okay, this is also not cool, you know, the pressure was nice. Okay, I made a mistake, so let's try to solve it again. But here one system that you can understand the weather, okay, weather is in the lowest line. So let's stop the system, and then edit the visual designer again. So this was fine, okay, this value, if it was 15, totally okay. But the cursor for humidity, let's take, instead of 30, let's take it as 40. And for weather, let's take the cursor, instead of 40, let's take it as 50. So I think so now it will be better. And we can do another thing. This display message, we can just delete it for now, and let's extend this end, okay? The display has to be done after the cursor has been set. So that was one mistake that happened. So now I believe that everything will be fine. So save and let's see. So now the lines are perfect, isn't it? So it is rainy showing. So now let's increase the value of 1008. So it is still rainy. Okay. So let's take 1010. 1011. So it is sunny or cloudy. Okay, 1011. Okay, sunny or cloudy. and then 1012, sunny or cloudy, 1013, sunny or cloudy, 1014, sunny or cloudy, 1015, sunny or cloudy, 1016, sunny or cloudy. Okay, 1016 is sunny. So these are the changes that happened. So anyways, if you place the values of pressure 1016, okay, where in the formula in your calculator, you can calculate it. Which formula? This formula right here, okay. So you can write 1016 here, divided by 10, you will get a value which is greater than 0.25, okay. Minus predicted weather is just basically 23 here, e to the power exponential to the power 23 divided by 7990, according to the formula that we have placed. Just place it and then you will get the differences, okay. So I guess you have seen one new approach from what are the different approaches you have seen so far, which means you can add the peripherals. For this experiment, you have seen some differences from the previous experiments, previous projects, okay, previous videos that I have provided. So if you try to compare between the previous systems and this new system, what we have done is added the peripherals from the flowchart instead of going to the import project flip. Okay. Next, we can see another difference here. So for each and every variable to be displayed, what you have taken is you have set the cursor differently, okay, in the loop execution side instead of the display. Okay, in the display, what we can do is if we set a cursor by default, which means that is basically for showing one line, but we have 4 lines here. First for reading the temperature, second for the pressure, next is humidity, and the last one is for the weather. So we have 4 messages to display. So if we select the cursors manually, then you can make some difference in this output side as well, you know. And another is temperature can also be controlled using this pressure sensor, okay. So altitude can also be read. This is another function. So there are many functions that can be done using digital pressure sensor, but for here we are using one formula, so we have just set the value of 23. And also we have learned how to split the flowchart, because if you wanted to add this full area, okay, this full functions in one line, is that possible? You're trying to squeeze this message, okay, but still you have a very limited amount of space. So that's the reason why if you have to design a flowchart which is out of this blue box right here, and you need to add more functions, then how you can split your full execution cycle, or maybe display cycle, or maybe like your setup cycle, whichever or whichever function you want to split, that can be done. Just place a right click and use this split function for whichever part you want to do it, okay. So I hope this overall system is clear to you, and you're going to utilize this flowchart making design for your future projects, and I will be really helpful. I will feel myself helpful enough for all of you, and I will feel great actually, because if you can utilize this for this knowledge, basic knowledge for future, and I think it will be better. So this is one simple weather forecast system, but if you want to add like location or additional features, you can use some additional sensors, and modify your system as well. So thank you very much for listening to this video for learning this weather forecasting system, and try to implement these in real life as well. Okay, so the sensor name is BMP, you know, the name of the sensor, BMP 180. And anyways, thank you very much. So see you in some next experiment or next of any project video. Till then, Take care and stay as safe as possible. Okay, bye for now.